family 35, women 36. Now, what did they say? Let us write. A researcher has the data for preferences of women and men regarding the, okay, it is their preference. So, they went to 131 men here. Okay, they went to 131 men. 96 men chose joint family, right? 35 had preference towards what? Nuclear family. They went to 530 women, and out of which 170 voted for or had good preference of joint family, and around 360 for nuclear family. Now they want to see, is there, whether, their opinion towards, joint family for men and women are the same, or they are significantly different from each other. So when you look at the data like this without testing, what do you think, class? When you look at the data, do they have similar opinion about joint family? No. We don't know, because they went to higher number of women, no? They only went to 131 men, out of which 96 liked joint family. Now, they went to 530 women, out of which 170 liked, and more like nuclear family. So I will say that, okay, the number, sample size is not very similar, right? Okay, then you can actually take percentages, and without testing also, you can see that, oh, this is very different. But social scientists will not approve unless otherwise you really test whether the samples are significantly, are they different, their opinions are different or not. So, because men and women are nominal data, they would have coded men as, 1 and women as 2. And joint family, they would have coded accordingly. Okay, they have numbers. Like, on a scale of 1 to 100, they have numbers for this, continuous numbers. So now, one is nominal and one is continuous variable. Okay? So that is why you are actually going to use chi-square. So then chi-square, it can be very easily done, with the software. But, this is actually the formula. So quickly, I'm going to look at it. So the chi-square, this is what it is. Sigma I is equal to 1 to k. Observed, observed variable of I minus expected, expected value of I, the whole square divided by EI. This is the equation. So OI is actually observed frequency, EI is the expected frequency. Then how to calculate expected frequency is given. So that is EI, expected frequency, row total into column total divided by grand total. So row total, this is the row total. Okay, into, what is it? Row total into column total into divided by grand total. So row total into column total. So here it is 131 into, here it is 266 divided by, the grand total, right? 661. So like that, for everything you have to take, right? So let us see what they have done rather than we waste our time on it. So you have, in this current scenario, the expected frequency can be calculated by the following method. So E1I is 131 into 266 by 661. 131 into 266 by what? By 661. The second one is 131 into 395 by 661. That is 131 into 395. So you have the same row, this into this, same row into this. Like this, now you will take this also. 530 into 266, 530 into 395. So you have all this data, they have calculated, right? They have calculated all this. I don't know, you are going to have MCQ, or you have to write the answers, solve the sums. $50 marks as MCQ. Okay, so I don't think, if you get also, you may have to calculate it. Okay, so you have, so so once you see, you make all this table, you make the table, and then you have to see now observed frequency, which is from the table. expected frequency you have calculated, you have put it here, correct? Like this, you have 4 expected frequency which was calculated. Observed frequency you have already put it up from the table. Can you see, class? And then observed minus expected, you have put that in the table. Then you are squaring it, you are doing that. And then finally you are calculating chi-square, right? So this is, your chi-square frequency, which comes to 74.1415614. So you fill the table, and then you need that distribution table, chi-square distribution. There is a manual book, okay? So you have calculation of chi-square, calculated value is 74.16, and assume that the degree of freedom is equal to 1. It is not assumption. There is only men and women. So that number is n. Degree of freedom is n minus 1. So that is why degree of freedom is 1. So chi-square value at 5% level of significance, one tail test and 1 degree of freedom is 3.8141. So, okay, so for this kind of a degree of freedom, right, and for 5% significance level, the value of chi-square is 3.841. And our value is 74.16, which is above 3.841. So what does it mean? You can check the chi-square value for significance with the help of one tail test. So you need to go to that manual book, and there you have to choose the column one tail test. Then the graphical representation, will come like this. So rejecting the chi-square value. So it is beyond or above, that value. It can be observed that the value of chi lies in the rejection region. So you are rejecting the null hypothesis. What is the null hypothesis? So it can be observed that the value of chi lies in the rejection region because it is 3.841, say above 74. So that less than 2 groups, less than 30 t-test. 2 groups above 30 z-test. 2 groups, more than 2 groups, you do have ANOVA, analysis of variance. Then I told you what is non-parametric test. When you use nominal, variable, ordinal, you use non-parametric. Now we look at correlation and regression. So correlation and regression is, something. Okay, so what is correlation? So there is a positive association between income and income of a person and buying of luxury products. Okay, higher the income, there is a higher chance that you might buy luxury products. So this is correlation. So correlation depicts the degree and type of relationship between variables. The value of correlation lies between -1 and +1. Okay. So correlation value of 0 indicates that there is no correlation between two variables. So what does -1 means? There is negative correlation. Say for example, when the price of a product becomes high, the purchase of the demand for that particular product becomes low. So that is negative correlation. Price and demand is actually negatively correlated. Quality and demand, or quality and sales. Quality of the product is high, sales of the product will be high. So the quality and sales are positively correlated. There may be no correlation between the gender of the buyer and the sales of a particular product. If there is if men and women both use toilet soap. So is there any connection between, women only uses toilet soap and men won't use? There is no connection between the two. So in such cases, your correlation may become 0. Okay, so correlation is between -1, +1, and then in the middle you have a 0. So then you have quickly, then you have techniques like So okay, regression is what is then? Regression is what here. Okay, regression is, so correlation is, the association. So is there any an association between income and buying of luxury products? So that is correlation measures association. What is measured by regression? Impact of advertising on sales of a product. So when I increase the advertising of the product, the sales increases. So I am saying that, so in order to establish regression, you need to have correlation. So we have to first say that advertising has a positive association with sales. Okay, so correlation is established, positive correlation. Now we say that when I impact advertising by budget by 25%, there is a 10% increase in the sales. Are you getting it? So you are actually measuring the the impact. So you measure the impact with regression. Okay, 20 marks description is there, na, Rima. So you may get this kind of a question. I don't know because I have not done the question paper that is done by the college. There is also one more problem for regression also in your SLM. Do you want me to explain that to you through that explanation? So there is an regression problem also. Okay, so did you understand correlation and regression? So correlation is you measure association with correlation, and regression we measure the impact. Okay, if I increase the advertising budget by 25%, what will be the corresponding impact on sales? Okay, you can measure all these things. So then there are very simple tests like okay, then you have things like factor analysis, right? So now these are only you have. Let us try and see when I am teaching. I'll try to show you. I'm not sure. So factor analysis also is an advanced technique where actually, let us just look at what is written in your example. The factor analysis method is used to reduce large number of variables into a relatively small number of variables. So for example, let us understand the concept of factor analysis with the help of an example. Assume that an organization needs to analyze two factors, employee and product. So employee who possess knowledge, appearance, and availability. That is okay. So employees, knowledge, employees appearance, employees availability. Okay, and then another factor is the style of the product. Okay, color, size, of the product, color and size of the product. Okay, so there are two things. One is product related and one is employee related. So what you actually do is you write all these things and then you do the factor analysis. So generally what will happen is factor analysis will throw you a table wherein which all employee related factors will come together and sit, and all product related factors will come together and sit. Okay, so then you are actually calling it factor 1. So factor 1 goes and sits together in the table, and then when you will be looking at, you will see that okay, employee values have got high high values, and Cronbach alpha booleans. Okay, so you have high values so you will call that okay, this particular factor, that means एक column में employee related का values ज़्यादा है. So then you will call all of them, which is above 0.6, you'll club all of them together and they will have some commonality. So that you will call as factor 1. In the second column, all product related attributes would have high values, and that you will call as product factor. So in this particular way, you can actually decide how many factors influence a particular sales. So in sometimes, okay, the design factor may club together, or for a car, and then the price factor may club together for a car, and the attribute of the customer wants lifestyle, customer wants this and customer factors might come together. So that could be third factor. So you can actually pool in and factorize different variables together. So then what we will call this knowledge, appearance, and availability together, we will label it and call it employee factor. And factor 2, we will call all of them and then we'll label it as product factor, right? So then later when you do data analysis, you can actually make them into one single variable. You can do a whole lot of things. So there is factor analysis. Then you have the cluster analysis. What is cluster analysis? You actually go collect data from respondents, right? About whether they would like to, what they want to in a car and all that. You collect data from them. And the customer data, you can actually run a cluster analysis, and you can make groups in the clusters. So what are you trying to do? You can identify homogeneous segments from a heterogeneous data. You are actually doing segmentation. So you can see how many segments really exist. So it is an automobile market again. You might find, customers, there might be, a set of customers who give a lot of importance to the price of the car or the economy of the car. Then there could be one group, maybe another, 1,000 people, who give a lot of importance to the style and the luxury and the pleasure of driving of the car. And there could be some other, people who want a good life, an average, driving experience and a very good economy in price, but they want a sedan also. They want a little bigger car. So you might say the first one is, the economy buyers. The other third one is actually the luxury or the high-end car, buyers. And the middle one is a sedan, or a compact sedan type of customer. So you can do this cluster analysis. Same you can do with discriminant analysis also. So in cluster analysis, we need continuous data. For discriminant analysis, we use categorical data also, right? So in a bank, people, banks use discriminant analysis to also create decision models, whether to give a person loan or not. These kind of things are actually checked with discriminant analysis. So, this kind of small things are given in your textbook. Some examples are given. So they might ask you conjoint analysis kiske liye use karte. So conjoint analysis is used for product design. Okay. So, we can do all these exercises can be done with SPSS, with data sets, that can be done. So here, because we are only discussing the theoretical part of it. So conjoint analysis is a data analysis technique that is used in marketing research quite a lot. This is used, especially for product design and that. So conjoint analysis is used to determine the parameters which majorly influence the decisions of the respondent. So manually also it is done. I know I have once done this exercise in which we gave, what people look for in a house. We had done a small project for a builder. What is it that people look for? Good locality, a play park, good parking, lot, availability of essentials nearby, and definitely the design and the beauty of the place. So you put all these attributes, alag-alag strip mein we put it up together. And we give, the respondents, you pick, this, and, you pick and, you can actually give each of it, how important it is. The most important things, you put together. And the things which are not so important, you can actually put it aside. So like this, to know what are actually, when they look for buying a house, what are the most important things, for them. And what are the things they are ready to negotiate if you want to see that. Okay, so 2 or 3, strips they may, discard. Say I gave them 8 attributes and I told them, you take 5 important attributes. And first I told them, take the most top 3. Okay, then I get the top 3. Then again I do that, then I tell them to take 5. So like this, we get, what exactly they want as far as, when they look for a house is concerned. So you can use a conjoint analysis for these kind of techniques. And you can use MDS. MDS I will be showing you in multi-dimensional scaling. I think there is a positioning chapter which is coming up. There I will show you MDS. So MDS is multi-dimensional scaling. You actually can use, you can use perceptual maps, and you can see, say for example, this is another technique which is widely used. In this method, a perceptual map is created on which the special description of a respondent's perception. So there will be, on the x-axis you will have, the x-axis you have price, and y-axis you have quality, right? So on price and quality, you have asked, customers to put up different brands, measure different brands. So high price, but high quality, right? Say, for example, let us take the shoe market. So if I am the customer, high price, high, quality, somewhere on the, the right side of the upside of the quadrant, I will put Nike, right? And then low price and medium quality, I will put, say, Power shoes. Okay. Low price, quality, acha, average quality. Then, I might also say, high price, then low quality. So if I feel that, okay, certain Puma, this shoe is not very good, I'll put it there. So like this, you can have two different variables, and you can put multiple brands on the same, graph. That is perceptual map. That is definitely part of our positioning chapter. Then we will see it. So this is, summing it up. So what I have not done. Okay, let's sum up. Let's tell you what is it that we are going to start in the next class. So here today we looked at analysis of the data collected. We also looked at hypothesis, right? We looked at hypothesis. We said how we should collect the data, how we should code it, what is hypothesis, what is independent and dependent variable, how hypothesis are tested. We took the names of certain data, like we talked about non-parametric and parametric tests. So when we are using interval scale or continuous data, the test which we can conduct is called as parametric. Metric means 1 to infinity, right? And then non-parametric tests, we are using nominal category. So we discussed that. Then what did we discuss? We discussed chi-square, t-test, z-test, so we only discussed them. So what I am trying to do, so that is the summary. What I have put up as extra portions. So naturally, I did not have time for extra portions because 2 hours, we can only do so much. So what I am going to do is I might, in the next class, first maybe 20 minutes, I will show you, I'll try and show you the SPSS, software. I'll show you how to put data and all in the first 5 minutes. Okay, are you learning SPSS, the decision sciences class? Have you learned SPSS anywhere, or Excel data analysis? Are you learning all this data analysis techniques somewhere? Okay, no answer. Thank you. So